Here's the next question, number 31. The circuit shown is meant to supply a resistive load RL from two separate DC voltage sources. The switches S1 and S2 are controlled so that only one of them is on at any instant. S1 is turned on for 0.2 milliseconds and S2 is turned on for 0.3 milliseconds in a 0.5 millisecond switching cycle time period. Assuming continuous conduction of the inductor current and negligible ripple on the capacitor voltage, the output voltage V0 across RL is dash. Okay, so a lot of information is given to us. So let's call the two voltage sources given as V1 and V2. Now, since the question says that only one switch operates at a time, S1 is on, then S2 is off, and then S2 is on, and then S1 is off. So that is the condition given. So in this case, the time period is very important. So here we have that S1 is turned on for 0.2 milliseconds, and then S2 is turned on for 0.3 millisecond, and the total time period is 0.5 millisecond. So we'll call this as T1 and we'll call this as T2. Now we are asked to find out the output voltage V0. So the question says that assume continuous conduction of the inductor current and negligible ripple on the capacitor voltage. So this tells us that the output voltage can be calculated by finding the average voltage here. Average output voltage. Average output voltage with respect to the two inputs of V1, V2 and the time periods T1, T2 along with the total time 0.5 millisecond. So I'll write that down here. So the average output voltage V0 is written as V1 T1 plus V2 T2 divided by the total time period T. We have our values of V1, V2, T1, T2 and T given in the question. So we have V1 from the figure as 10 volts, V2 from the figure as 5 volts, T1 given to us as 0.2 millisecond, T2 given as 0.3 millisecond, and the total time period T is given to us as 0.5 milliseconds. So that's into 10 power minus 3, right? Okay. So let's substitute all of these values into the formula here. So we get V0 is equal to 10 into 0.2 milli plus 5 into 0.3 milli divided by 0.5 milli. Okay, so now if we are to solve this, V0 would be equal to 7 volts. So the answer here is 7 volts. The output voltage V0 across RL is 7. Well, I hope this explanation is clear and it has helped.